Hi everyone, welcome back to the channel. Today I'll be solving the IGCSE Mathematics paper 42 for question number 4a. Now this question is about probability and we're told that a shop gives each of 1,000 people a voucher. 28 people use their voucher. The shop now gives 16,500 people a voucher. Calculate how many of these people are expected to use their voucher. So how you would normally solve this question is by first calculating the probability that people will use a voucher. So in our first original statement or original situation, we had a total of 1,000 people and 28 of them would use their vouchers. So the probability of using their voucher should be 28 by 1,000. So you can simplify this, but it's not really required. But anyway, uh, now that we know what the probability is normally, we would have to find out how many of those people following this probability in the 16,500 people would actually use this voucher, where the probability will apply to them. So you would have to multiply the probability with the total number of people. So essentially that's 28 by 1,000 into 16,500, and that is 462. Now the reason why we do this is let's for example take a much simpler situation. Let's say 1 in 4 people like the color red. So if we were asked how many people in a total of 20 individuals would like the color red, we would simply uh, write the following ratios where x would be the number of people that like the color red and 20 would be the total number of people. So you'd know that to calculate x, when you take the ratios, it would be 20 is equal to 4x. So 20 divided by 4 will give you x. In the same way over here, when we had 28 people that used the voucher out of a total of 1,000, and then in our next situation we had 16,500 and we had x as the number of people that would use the voucher. X would then be 16,500 upon 1,000 into 28, which is the exact same thing we're doing over here, and you should get the answer 462. Now for part B, in a class activity, all 15 students wear hats, 7 wear red, 6 green, and 2 white. So one of the students is picked at random. We have to write the probability that the student wears a red hat. So P red is supposed to be 7, which is the number that wear red, and 15 upon 15, where 15 is the total. And this can't be further simplified. So we'd write the answer as 7 by 15. Now for part 2, we're told that 2 of the 15 students are picked at random. We have to show that the probability that these 2 students wear hats of the same color is that much. Now, given the situation, we need to think about what outcomes might be possible that satisfy this probability here. So if I had 2 dashes for every pair that was picked, the cases where the hat colors are the same were if it was red and red, or if it was green and green, or white and white. So it can be any of these situations, and we have to combine these probabilities to give us the final answer of 37 by 105. But how exactly do we combine them? So in this case over here, we have R and R, as in red and red. So both of these probabilities are occurring simultaneously. So that would basically mean this indicates probability of red into the probability of red, as in the probability of a student wearing a red hat being picked into the probability of a student wearing a red hat being picked. So we know that the probability of a student wearing a red hat in the first case will be 7 by 15. Now we would have to multiply it again with the probability of wearing a red hat. But the difference here is or the key point over here is it will not be 7 by 15, because if we're taking out one student from this entire batch that had a red hat, then we'd have one less student that had a red hat in this entire batch, right? And we would also have one less student that would be in this entire batch. So instead of 7, it would be 6, and instead of 15, it would be 14. So it would be 6 upon 14. Now we have the or. So it could be red and red hat, or green hat, or white and white hat. So when we have this or function over here, it means that it can occur, but it cannot occur at the same time as the other probability. So it will be either one of those three situations taking place. And when we have the or operation, we have to do addition, not multiplication. Multiplication applies for and. So we would have to add the probability of the reds with the probabilities of the green situation happening, where the green situation would be the probability of green into the probability of green, because uh, both the students would have to wear a green hat, and of course the second probability will again be reduced by 1. So continuing, the probability would be green into the probability of green, and we know that there were 6 students that had green hats and a total of 15 students, so it would be 6 by 15 into 5 by 14, because again it has to be reduced. Now the reason why it's resetting back to 15 and not being further decreased to like 13 or 12 and so on is because the green students being picked out after the red is not a consecutive event. It is the case where it may be happening instead of the situation where students with red hats would be picked out first. So you start off with the very original amount, which was 15 as a denominator. We do not have it decreased any further. Now, after that, we have to also combine the probabilities of the students wearing the white hats. So that would be plus probability of white into probability of white. And white was 2 out of 15. And now we'll reduce it again to 1 by 14. And we have to add this yet again. So if this is correct, then I should be getting 37 by 105. And yes, you finally get 37 by 105 in the end. Now moving on to part 3. 3 of the 15 students are picked at random. Find the probability that at least 2 of these 3 students wear red hats. So we're working with red hats again, and this time 3 students are picked instead of 2. And our criteria is that it has to be at least 2 of the students that have red hats. So let's start off with 2 students having red hats at first, and then the third student would have not red, and the next situation where all 3 of them have red hats. So first off, I'll start off by breaking down how we find the probability of not red. That's basically the probability of green and white, or we could just do 1 minus the probability of red. So the probability of red was 7 by 15. So not red would be 1 minus 7 by 15, and that is 8 by 15. Now when we combine these probabilities, the first situation where it's red, red, and not red, the probabilities would be 7 by 15 into 6 by 14, and then finally into not red. Also note that we have to reduce the numbers by 1 again because these events occur consecutively. So for this one, I know I wrote 8 by 15 over here, but in fact we cannot write 8 by 15 because in our current situation, there are not a total of 15 students after the first two were picked. It would be 8 by 13 students because 13 students would be left behind. That's why you should also know the next important point is that this has to be multiplied with 3 because there are three different ways this first situation can take place. It can be red, red, and then not red, or it could be red, not red, and then red, or it could be not red, red, and red. You could also add all of these probabilities together, but it makes no sense to do something as time consuming because multiplying with 3 is in fact the exact same thing. So this equation over here reflects the situation we've mentioned above. And for this situation over here, it would be pretty straightforward, 7 by 15 into 6 by 14 into 5 by 13. We're reducing the number each time because these events occur consecutively, and taking out one student from the entire batch would reduce the amount overall. So now we'd have to sum all of this. We'd have to sum the first situation with the second situation. I've written it quite messily, but I'd obviously suggest writing it in a neat, understandable way. This is only for the sake of explanation. So when you combine all of this, you should get 29 by 65. So that's it for this question. If you have any doubts or questions you'd like us to solve, please leave them in the comment section below. If you have confusion with other topics, we do have a lessons playlist. Feel free to check that out. If you found this video helpful, please consider liking and subscribing, and I will see you in the next video. Thank you.